Welcome back to the 22nd part of Debugging at Scale, where we inspect every packet on the network to find out where the protocol failed us. Wireshark is a free open source packet sniffer and network protocol analyzer, originally developed by Eric Recorla and Gerald Combs. It supports capturing packets on practically any network interface or protocol you can imagine, and is an invaluable tool in our debugging arsenal. Wireshark displays packets in a tree structure called ProtoView. This allows easy identification of protocols and ports used in the current session. It is very similar in basic functionality to TCP dump, but the graphical front end makes it much easier to work with. Capturing raw network traffic from interfaces requires elevated privileges on some operating systems. This caused security issues in the past and could be a serious risk. A more secure approach is using a tool like TCP dump to capture packets into a file. We can then open the file with Wireshark in user space with no special permissions. Both tools are highly synergetic and useful together. I will discuss TCP dump in the next video. Many users of this tool do very low-level networking work, security, browser development, etc. As a result, most of the tutorials and documentation is geared towards developers doing system-level development. This is a shame, since this tool is remarkably helpful even to high-level application developer tracking web requests and web service dependencies. To be fair, the network monitoring tool built into the browsers would probably satisfy most application developers. Both Chrome and Firefox have amazing tools that show the flow of network requests. These should be your first recourse when possible. Wireshark makes more sense when you can't resolve issues with the existing tools or are building an application that isn't a standard web interface, for instance, native mobile app. In the past, I used it to discover a case where a native application was failing when the server returned chunked HTTP responses. This required inspecting successful and failed requests to understand the difference. You can download and install Wireshark from their website. It's open source and free for use. Notice that there are separate steps to install command line tools, etc. So I suggest reviewing the instructions. Once you install and launch the application, you would face this UI. Here we need to decide which network interface we wish to capture. This can be confusing if you don't come from a networking background. You might debug a local server and assume that you need to debug the EN0 interface. This isn't the case. If the server is running locally, you should debug the loopback. Look at the activity graph on the right-hand side. This shows you instantly which interface is active and which one isn't. You probably only care about active network interfaces, so it has to be one of those. But even when we pick the right interface, the challenges are still severe. Wireshark is a packet capture solution. It doesn't distinguish between apps. We get a lot of noise when connecting to an interface. Once we pick the loopback, we can see the full data. And as you can see, it's a constantly updating screen. The volume of TCP traffic is pretty big, and I'm not doing anything yet. All of that is just background noise, and it's interesting to dive into on our spare time, but probably not what we want to look at when we're trying to narrow down a damn bug. Luckily, we have display filters that let us remove the noise by focusing only on the specific port which we're interested in, with the condition TCP port equals 8080. Notice that my server is running on that port, which makes it pretty easy to filter everything else. This brings down the noise considerably, as you can see here. Still, there's a lot of noise because of the protocol. Notice that Wireshark is smart enough to recognize and even highlight the HTTP request made to the server. Assuming I don't care about the nuances of TCP, I can further reduce the noise by adding an HTTP condition by adding HTTP to the previous condition. This will limit everything to only HTTP requests and responses. Again, very useful stuff that can have a big impact if you're dealing with many HTTP requests and connections. The display filter syntax is pretty powerful and supposedly and supported by auto-completion within the filter bot. You can read about it in the user guide. You can filter by IP address, not as useful for loopback, source port, hostname, protocol, content, and so much more. This is just the start though. You'll notice the second entry is the response from the HTTP server, and it's marked as JSON. Wireshark detects the response type and displays it conveniently, as you can see here. On the bottom portion of the screen, we can see the raw packet display, which is typical for sniffer tools. In the bottom left corner, you can see the hexadecimal values returned from the server. On the right, you can see the matching ASCII or UTF-8 characters matching the hex. This is readable, but might be a bit unpleasant for developers that aren't accustomed to debugging network traffic. If you look one level up, you will see a tree marked as array. This is the JSON array from the response. To be clear, Wireshark detects the HTTP protocol, then detects that the response type was JSON. It then parses the JSON and displays it as a tree for you to read conveniently, even if the packet is minimized and obtuse. When I make selection within the tree, it highlights the place in the packet, so we can inspect the surroundings and see that everything is in order. This lets us instantly see what went on when connecting to a server client and act accordingly. I'd love to go into more details about Ethernet networks, decrypting HTTPS, debugging devices, and other complexities, but this is mostly the pain of configuring OS-specific settings, browsers, and a whole mess of things to look into the SSL traffic. Personally, I try to disable security for debugging. It makes this much simpler, but sometimes there's no choice. I don't reach for Wireshark often in my day-to-day work. There are usually simpler ways to solve these issues than inspecting network packets. But when I need Wireshark, it's a fundamental change. The capture process is trivial when compared to far more complex tools. The capture filters are powerful and fast. As a general-purpose network protocol analyzer, it's absolutely fantastic and has so many deep use cases I can't even begin to get into. In the next video, we will discuss TCP dump, which is deeply related to Wireshark. If you have any questions, please use the Slack channel to ask them. Thank you.